Okay, I'm Shirley Anderson, and I'm going to go over determination of gender, genes versus hormones. So, sex chromosomes, you either have genetically an XX or an XY. There are variations to this, which I'll go over a couple examples of those later. So, you always get an X from your mother, and then your father can either give you an X or an Y. So, if you have an X from your father, leading you to be XX, then you would be a genetic female. And if you get a Y from your father leading you to have XY, you'd be a genetic male. So in the presence of Y, embryo becomes male, and in the absence of Y, the embryo becomes female. So if you only have an X chromosome, you will survive. Two X's are necessary for normal reproductive function. However, you can still survive with just one X chromosome. But now if you only have one Y chromosome, this will not lead to survival because the X is a much bigger chromosome and it has a lot of essential genes on it, so it will not survive in that sense. So bipotential occurs up to 7 weeks of development. So what this means is that until 7 weeks, or around 7 weeks, that embryonic tissues do not look different from one another, so you can't tell if it'll develop into a female or a male at this point. Morphologically, the embryonic tissues look the same. So bipotential gonad has a medulla and a cortex, and so then eventually, after this 7-week period, the medulla of that bipotential gonad will turn into testes if it's male, and then the cortex of that bipotential gonad will turn into ovarian tissue eventually if it is female. Now, sex determination depends a lot on this SRY gene, and this SRY gene, this stands for the sex determining region of the Y chromosome, so this SRY gene is on the Y chromosome. So in the presence of this SRY gene, the male, it initiates Wolffian ducts, and so those Wolffian ducts will eventually develop and form into more male sex characteristics, and then the absence, and those sex characteristics are more so internal, and then the absence of this SRY gene would cause it to be female, and this would end up leading to the Mullerian duct system kind of taking over and turning into female sex characteristics. So let's go over if this SRY gene is, if there's a Y chromosome and there is an SRY gene. Also to note, it is possible to have a Y chromosome without an SRY gene, and that brings about its own differentiations among that person that is developing. So just less say like testosterone and other androgens that would have been brought about if there were an SRY gene. So, though in a normal typical case, the SRY gene will produce TDF. TDF is testes determining factor. So this activates genes that direct gonadal medulla into testes. So as I mentioned earlier, that bipotential gonad tissue, the medulla, turns into testes due to this essentially SRY gene. So then the testes differentiate, and once they do that, they secrete 3 hormones. So the Sertoli cells, which is in testicular tissue, secretes anti-Mullerian hormone. And if you remember, the Mullerian duct system has more to do with female development. So once the testes have differentiated, Sertoli cells secrete anti-Mullerian hormone so that it will suppress the Mullerian and make the Mullerian ducts regress. Kind of just gets rid of those Mullerian ducts since they're not needed, since this essentially is turning into a male. There's also Leydig cells, and they produce androgens and DHT. So testosterone, which is an androgen, converts Wolffian ducts into the epididymis, the vas deferens, and the seminal vesicle. DHT, however, controls differentiation of external genitalia as well as the prostate gland. So they have seen cases where when there's no DHT secreted, the external genitalia doesn't develop, and so babies are born and they think that they look more female, and then they grow up, and a lot of the times testosterone will cause there'll be like a spike, and then their voice will drop and they have some facial hair, and so they realize that it actually was an XY male, but from the outward appearance it appeared to be more female because this DHT didn't differentiate that external genitalia. So now let's go through the female. There's no Y chromosome, so then there's no SRY gene. And so then in that case, the bipotential gonad tissue, the cortex part of it, turns into ovarian tissue. So in the absence of testicular AMH, which is that anti-Müllerian hormone, Müllerian ducts are able to grow and form and go about the path that they were originally set to do. And so that path would be that those Müllerian ducts form into the upper vagina, uterus, and fallopian tubes. And then with no testosterone, Wolffian ducts degenerate because they have to have, Wolffian ducts are thrive off that testosterone. So if there's no testosterone, you're kind of starving them, so they just kind of degenerate in a sense. And then with no DHT, external genitalia turns into female characteristics. Kind of like I mentioned before, that if there was a male and there was no DHT, they look more female on the outside, but in this case, there's no DHT because it was an XX and there was none to be secreted anyways, and so it turns into female sexual characteristics externally. So the female is kind of, in a way, this default that because there's no SRY gene, a lot of hormones aren't produced, and so it just kind of defaults into Müllerian toward female. So yeah, in the absence of a lot of hormones, it turns into female. So as I mentioned, I was just going to talk about a few variations. So, and as I mentioned in the very beginning, that it is possible to have just one X chromosome and survive. And so when someone is born with just one X, this is considered Turner syndrome. And a lot of the times when there's chromosome variations, so one chromosome or three chromosomes, they're infertile. So Turner syndrome, they are female, they look female, however they have some distinct characteristics, kind of like a truncated neck and other things that make them look and appear different. And they are also, yes, as I said, infertile, so they do not have normal reproductive function. However, they survive. And then XXY is Klinefelter syndrome. So because of that Y, they do appear, they are genotypically, they are male. So they have male characteristics. However, because it has two X's, they have also, so yes, they're male, but they have a lot of female characteristics, which would be kind of like enlarged breast tissue. Their facial hair, say, wouldn't be as prominent as a XY male. And they are infertile as well. So yeah. And all this information, I forgot to put a reference slide, but this all comes from, again, the book that this whole class is based off of, Human Physiology, an Integrated Approach by D. Unglaub Silverthorne, the 8th edition.